Okay, welcome. Today we are going to look at Tectonic Hazards Gateway 2 Part 3. So we will be focusing firstly on earthquakes. Earthquakes are the vibrations that we feel on the Earth's crust as a result of tectonic action below. So a few key things within earthquakes. The concept of earthquake that you must know, the concept of where the focus is, okay, where the epicenter is, and what happens after an earthquake, the minor tremors that come after, which are termed aftershocks. So these are three of the very key words that you must be able to understand and identify. When we talk about earthquakes, there are two main types that we can focus on: deep focus earthquakes and shallow focus earthquakes. So when you talk about deep focus earthquakes, they are the ones where the focus is between 70 and 700 kilometers below the Earth's surface. So because of the distance, the impact onto the surface level itself, and in terms of damage and destruction, is going to be lesser. Now for shallow focus earthquakes, you are talking about those that the focus is within 70 kilometers of the Earth's crust. So because it's very much nearer than deep focus earthquakes, this will cause a lot more damage because the seismic waves reach us a lot faster. What you see in this image here is the Richter scale. Richter scale is the scale which measures the damage of an earthquake. If you read through, you will be able to see the impact on land. Reminder, Richter scale is increased. It doubles in intensity with every increasing number. What this means is if you have level 2 compared to level 1, it is twice as damaging. Level 3 is twice as damaging as level 2. So it is not an arithmetic increase. There are 5 factors that will affect the intensity of an earthquake, the impact of an earthquake: population density, level of preparedness, distance from the epicenter, time of occurrence, as well as type of soil. Now these 5 factors all work in their own ways to either make the effect of the earthquake worse or make it more damaging as a result. Now very briefly, population density refers to the number of people who are living in the area. So the higher it is, the higher chance that more people get hurt in the earthquake. Level of preparedness refers to how ready you are to deal with an earthquake when it happens. So if the population is very prepared for it, the likelihood of them surviving or minimizing the amount of damage or death is going to be a lot higher as well. So level of preparedness is another important factor. Because seismic waves reduce in intensity the further they are from the focus or epicenter. If you have larger distance between yourself and the epicenter, the likelihood of you surviving or likelihood of suffering less damage is going to be a lot greater. For time of occurrence, imagine this: if it happens in the middle of the night, right? The people who are experiencing the earthquake may be asleep. They will not be able to take emergency action as soon as possible, and as a result, there may be more death and damage, death that's resulted or injury that's resulted of this. Consequently, if you survive the initial shake due to the absolute lack of electricity during an earthquake, it gets cut off. When people are moving around trying to escape, they may suffer even more injury as a result. So time of occurrence is a key factor as well. The last factor we'll talk about is the type of soil in the area. If you have loose soil versus compact soil, loose soil will vibrate more with the earthquake and therefore cause larger amount of damage. So type of soil is yet another factor that will affect the impact of an earthquake. This map here shows the location of earthquake distribution across the globe. Now, unlike volcanoes or full mountain distribution, earthquakes can occur wherever you have a plate boundary. Whichever type of boundary it is, whether convergent or divergent or transform, as long as the plates move, we will consequently feel it as an earthquake. So very importantly, when we are dealing with questions that talk about distribution of earthquakes, you still need to mention the plates that are involved, the distribution. Why is it that you always find them near plate boundaries? Okay. One of the key risks that is associated with living near earthquake zones is tsunamis. Okay, tsunamis is basically a large water body that is like a large wave that is sent crashing towards the coast, and it will cause widespread damage and destruction to coastal areas. Figure here shows how a tsunami actually occurs. One very important thing to note is for a tsunami, effective tsunami to be created, you have to have uplift of the seabed. If there's no uplift of the seabed at the first point in this diagram here, there will be no pushing forward or no dramatic push forward of the waves itself. So over time it grows, and then when loses speed and crashes down towards the coast itself, it forms a very large wave known as a tsunami. This causes a lot of damage to coastal areas. So what we see in these two comparative satellite photos is the before and after effect of a tsunami on this area itself. So questions may ask you to assess or describe what you see as a difference as a result of the tsunami. You need to mention where the damage tends to be focused. Are there areas that are not damaged? These are anomalies. Why is it that these areas that are heavily damaged are so? Is it because they're nearer to the coast? Is it because they're low-lying areas? So this is another type of data that can be given to you, a satellite photo. When you have an earthquake, services can also be disrupted as a result of your gas pipes, your water pipes, and even your infrastructure like roads and all these communication devices being destroyed in the process of the earthquake. So disruption of services is a common side effect of an earthquake. With earthquakes, landslides are also common, especially when you have loose soil along the hills or mountainside areas. When you have vibration, the soil can come crashing down, destroying everything in its path as well. In terms of impact that's felt by the people living in the area, destruction of property is the most common impact. Now, whether it's by tsunami, by landslides, or simply from the vibration effect of the earthquake itself, property destruction is one of the main things that we feel, besides death. Okay, like I mentioned earlier, the other impact is death. Death is an individual issue because the person dies. It is also a social issue because there are people who survive you and they have to deal with the fact that you're no longer around as well. So economically, there is also a damage to the individual, the family group, as well as to society at large. What you see here in this table is a list of various earthquakes, the time where it occurred, the intensity on in terms of Richter scale, and as well as the number of deaths and overall impact. Now, you do not need to know all of them by heart. However, these will serve as very useful examples if you're trying to illustrate one of these factors that we mentioned earlier. In the earlier video, part 2 of Gateway 2, we mentioned about volcanoes, types of volcanoes and eruptions. Now we're going to look at the three main general categories of volcanoes in terms of destructive ability: the active ones, the dormant ones, and the extinct ones. So these refer to how intense or how high the risk it is in terms of an eruption, the next eruption. Next, we will talk about some of the risks of living near volcanic areas, one of which is destruction by volcanic materials. So all volcanoes will erupt with emission of lava of some form, and given the heat and the destructive nature of it, if you are in direct contact with it, you will die. Your possessions will get destroyed. So these pictures serve to illustrate that. Pollution is another negative effect of living near a volcano. When you have a volcanic eruption, ash is always erupted into the atmosphere. As a result, it gets trapped within the atmosphere itself, causing global dimming. It can also lead to risks of aircraft flying. As a result, you can have grounding of certain airspace when you have a volcano that erupts. Now, in contrast, there are four main benefits of living near volcanoes that you will cover: fertile soil, precious stones and minerals, or building materials that can be excavated, the concept of tourism in the area, as well as geothermal energy. Fertile soil benefits the farmers in the immediate area. Volcanic ash is high in nitrate content. As a result, it is very easy to plant anything on volcanic soil. Examples include places like Bali and Indonesia. In the volcanic material that's erupted, very often you do find precious stones and minerals, including things like diamonds and rubies. Now, this doesn't directly benefit the people in the immediate area because you don't get to keep it. It actually belongs to either the government or to the company the government has given the rights of the land to. However, you do gain employment. So for the people there, their benefit in terms of precious stones and minerals is in the form of employment. Now, for the concept of tourism, right, when you have a volcanic area, it is a place of great scenic beauty and intrigue, and at times also culture and history, in terms of like the Pompeii example, where it's a form of dark tourism. It encourages tourism to the area. Now, for the people living there, it means that you are now exposed to a whole range of tourism related occupations, from tour guides to hotel guides to even food operators and transport operators as well. So this gives them benefit in the form of tourism related jobs. Lastly, for geothermal energy, right? Geothermal energy is basically energy that's obtained when your underground water is heated by the volcanic activity, and it comes onto the surface as steam. It can be harnessed by turbines to produce electricity for general usage in the area. Now, countries who harness geothermal energy generally make the local population pay very little for electricity. It's very good because it's clean, renewable, and it's very, very cheap. So benefit for the local is a reduction in cost. It isn't a increase in salary, but it's a reduction in cost. Now, for the final bit in this video, I want to highlight one of the gateway pit stops for you. This is a topographical map that you may see something similar in your assessments. So interpretation question may include a topographical map like this, and they may ask you to interpret certain information from this map. So one potential question may be they will be referring you to one particular grid square in this map itself. For example, if I refer you to grid square 6216, there are some coastal settlements in the area, so we can talk about what are some of the risks that these settlements may face as a result of being located so near Makushin volcano. So it is not normally hard map skills, but in this case, most of the time it is interpretation questions. Hard map skills like grid line references, bearings can occur, they can test you, but it's not common. So like the pit stop questions indicate here, there are some hard map skill questions like 4-figure grid reference of the crater, and other interpretation ones include like deciding which one is the steeper slope of the volcano. So gentle reminder, when your contour lines are very near one another, it indicates a steeper steepness. Okay, so these are some of the questions you may see in assessment. So this brings us to the end of part 3 of Gateway 2 on tectonic hazards. So stay tuned for part 1 of Gateway 3 that will be coming up very soon.